What is Ethereum? Well, it's a lot of things. It's first and foremost a cryptocurrency. You can see it listed on a website here like coinmarketcap.com. Okay, it's a cryptocurrency with a price that you can trade on a cryptocurrency exchange. You can send it around to other people. It works just like any other cryptocurrency. You can use it to pay for things. And you can see I have a little bit of cryptocurrency in my MetaMask wallet here. Here's some Ether. But Ethereum is more than just a cryptocurrency. It's also a blockchain. Technically speaking, the blockchain is called Ethereum and the cryptocurrency is called Ether, but most people just call this Ethereum. So these words can be used interchangeably, but technically speaking, the cryptocurrency is Ether and the blockchain is Ethereum. So Ether is the native cryptocurrency of the Ethereum blockchain. You can use it to pay for transactions. You can use it as a native cryptocurrency to send around, just like we're talking about. But the actual underlying blockchain itself is where the magic of Ethereum happens. So it is a worldwide computer that we talked about in the previous section. It supports smart contracts, which are just programs that you can put on a blockchain. And because of this, Ethereum has an unlimited potential for developers to create any type of application that they want to because it is programmable in this way. And that's what makes it so special. One of the best ways to get familiar with Ethereum is to just observe it in real time. And that's exactly what we can do on a website like etherscan.io. You can watch all the transactions and blocks being created on Ethereum in real time. So you can see all this. You can sort of approach this like a detective and ask questions like, hey, what is this? What are these latest transactions? What are these addresses? What are these block numbers here? Well, what you're seeing is all the transactions that are coming in real time. Again, blockchains are just peer-to-peer networks of computers or nodes that all talk to one another. And anytime new information is added to the blockchain, new transactions are created. And again, those transactions are grouped together into bundles of records called blocks, which are included on the blockchain. They're chained together to make up the public ledger. So you can literally just inspect some of these to see the most recent transactions and see what happened inside of them. Okay, just like this. This is an example of an Ethereum transaction. And you can see one of the latest blocks that was just mined here and all the transactions that were included in it if you want to see the types of activities that people are performing on the blockchain. Understand a little bit more about Ethereum, we can look at the history of blockchains and how Ethereum came onto the scene and rose to prominence to the blockchain that it is today. We can first start off with Bitcoin. So Bitcoin was the first blockchain in existence with the Bitcoin peer-to-peer electronic cash system. Okay, so I've got the Bitcoin white paper pulled up. This is the original manifesto, if you will, for how the Bitcoin blockchain should work. And really, this just started as a way to create a censorship-resistant money that could be transacted with across borders, that people couldn't tamper with, all right? And it was originally created by the anonymous Satoshi Nakamoto. Whether this was a person or a group of people, we don't exactly know, all right? But then came along Vitalik Buterin and several others who had the vision for blockchain beyond just Bitcoin. Because again, originally Bitcoin was just a blockchain that was designed to run a cryptocurrency, a money and nothing else. But Vitalik had a vision for a blockchain that could do things way beyond just cryptocurrency. So you can see that in the Ethereum white paper here. So Ethereum was created as a next generation smart contract and decentralized application platform. So the vision was to create an open, permissionless network that supported arbitrary programs that developers could come in to build decentralized applications. And you can see that idea was just penned in 2014. And so then Ethereum was launched in 2015. They had their ICO and their mainnet launch, and that was the beginning of the decentralized application movement that's been fueling blockchain development ever since. So that original vision for Ethereum was to create a blockchain that could support these censorship-resistant, unstoppable applications of the future, and it's evolved into much more than that over time. It's realizing a much bigger vision of a technology that can host digital money, global payments and applications, and to create a booming digital economy, to create bold new ways for creators to earn online, and so much more. So it's open all the time, 24/7. It has the promise to create a fairer financial system with decentralized finance or DeFi. We talked about some of that in the last section. We'll talk about it more coming up soon. And also the Internet of Assets. So this is very similar to the Internet of Value that we've been talking about up to this point, particularly with non-fungible tokens or NFTs, and a completely open internet. So this is another way of just saying Web 3.0, which we also talked about in the last section. And the most exciting thing that we're going to focus down on this program is the new frontier for development, because you can do so much with these smart contract programs that the possibilities are basically limitless, and there's a new frontier to be explored for developers, which I'm excited to take you through in this program. how does Ethereum work? Well, let's look at a couple different examples and see how you might do this with Ethereum. So we'll start with a really basic example of, just sending cryptocurrency around. This is one of the simplest examples of how you can use the blockchain in the first place, just connecting your wallet, specifying a recipient, and, clicking send. So for this example, we'll say that I'm going to send you 1 Ether from my account to yours. How does that work with Ethereum? So we're going to look at this in a couple different ways because, again, Ethereum has gone through a very long evolution from its initial launch in 2015 all the way to the blockchain it is today. And it's undergone several changes, which we're going to talk about later in this video on the road to the final version of Ethereum, sometimes called Ethereum 2.0. But let's look at the first version of Ethereum, Ethereum 1.0, and how it works. So if you're going to send cryptocurrency from one account to another, then you need a wallet, all right? You have an account that's connected to a network. It's got an address like your public key, all right? And your private key is what you use to sign transactions. That's like your password. So you connect with your wallet to some sort of, maybe web browser or mobile device, all right? And that talks to Ethereum itself. And again, Ethereum is a blockchain. It's a network of nodes that all talk to one another. And whenever you are, sending cryptocurrency from one account to another, you specify who you're going to send it to. You sign the transaction with your wallet, you broadcast the network, and it makes a round trip to the nodes of the network to get included in the blockchain. Now let's talk specifically about 2 things inside of here that are specific to the first version of Ethereum that we didn't talk about in the previous section when we looked at how blockchains work. So first, let's talk about gas fees, all right? So anytime that you do a transaction on Ethereum, anytime you make an update, you create a transaction, you send cryptocurrency, use a Dapp, you have to pay a gas fee. So you might have seen this, like if you're going to send cryptocurrency from one account to another, you specify the amount plus the gas fee. So what is this gas fee for? Well, essentially, it's one of the ways that people who run the network get paid. So on Ethereum 1.0, it has a consensus mechanism called proof of work, which is just like Bitcoin. We're going to do a deeper dive into consensus mechanisms later in this program. Okay, there's a specific lesson on that. But essentially, that's how the blockchain works, is anytime you include transactions in the blockchain, you have these miners that compete to complete cryptographic puzzles to include that transaction into the blockchain. Again, we're going to go into that more in depth later. But essentially, you can see a miner here as someone who essentially runs this node and is responsible for including transactions into the blockchain. And when you pay this gas fee, that's going to go help pay this miner who's financially incentivized to act honestly and actually run this network. Because you might say, hey, why would anybody run a computer 24/7 to support a public blockchain? It's because there are really good financial incentives involved where they can get paid to do that. And another reason that you have this gas fee is to prevent spam on the network, because you don't want a blockchain to just get included with a bunch of spam transactions. That's what this gas fee is for. Anytime someone's going to do something on blockchain, they need to have skin in the game and be willing to pay the cost. And, sending money around is a really good use case for that. Doing decentralized finance and swapping tokens is a really good use case for that. So that's how it works in the Ethereum 1.0 context with miners running proof of work. Now let's look at the next generation of Ethereum, which most likely is what Ethereum is going to be running when you're watching this video, is when Ethereum has switched to proof of stake. All right, so that's a new consensus mechanism where these validators are replacing the miners. Okay, so miners become validators, and in order to run the network, they have to take cryptocurrency and stake it to the network. So they take Ethereum cryptocurrency or Ether, they lock it up into a node, and they participate in running the blockchain. So again, we're going to get into that more in depth in the consensus mechanism section. But essentially, if you're sending cryptocurrency, you connect with your wallet, you pay a gas fee, all right? You broadcast that to the network, and then the validators, all right, who are running the network, achieve consensus on the state of the chain and include your transaction in the blockchain, and your gas fee pays them. Now, I should also mention in both of these examples, the blockchain creates new cryptocurrency as well. And that's another way that these validators or miners get paid. They get paid 2 ways. One from your transaction fee and also from new cryptocurrency that's created by the blockchain whenever new blocks are mined. So let's talk a little bit more about gas and specifically how it works, because this is a really common thing for people to struggle with when they start developing with Ethereum. So again, why do we have gas in the first place? It's to prevent spam on the network. We want people to have skin in the game when they're making transactions. And it's also used to help pay, validators who are running the network. Okay, so you can see different expressions of gas prices here. Okay, so you can see 87 Gwei is low, 87 Gwei is average, and 89 Gwei is high. you'll see these prices go up and down over time. This is the gas price. So let's explain that. I'm going to open my MetaMask wallet here and go through that basic example of sending 1 Ether. So if I'm going to do that, I can specify a recipient, all right, and then I can say the amount of ETH that I want to send. Let's just say 1 ETH, all right, I'm going to click Next. And here you're going to see this gas option. So MetaMask has some defaults inside of here, but I can then change this, okay? I can do advanced, and I can actually specify the base fee, the priority fee. So this is going to be the gas fee based on the units of gas. And then if I'm going to send this transaction, I click Save and Send. So here you're going to see it's going to cost, the Ether that I'm going to send plus this, small amount of Ether, 0.0002631 Ether in order to do this transaction. So it's the cryptocurrency amount plus the fee. Let's talk about how gas is actually calculated, because you see these values, like I mentioned a minute ago, 68 Gwei, 68 Gwei, 68 Gwei. So what is this? Well, Gwei stands for gigawei or Gwei, however you want to say it, which basically is a smaller subdivision of Ether. So you might see this is 68. It's not 68 Ether. It doesn't cost you 68, 66, 70. You can see these actually changing on me while I'm doing this. It doesn't cost you this much Ether, and it's not 0.69 Ether. It's not this has nothing to do with the actual fee that it's going to cost. So gas is an abstract unit. So anytime you do a computation on Ethereum, let's say sending cryptocurrency, you pay for that in units of gas. It's an abstract unit, kind of like gas in your car. And then you multiply it by the gas price. That's what this is here. 73 Gwei is the current gas price for every single unit of gas. So let's look at a calculator to explain that. All right, so you can look at this calculator on ethgasstation.info. This, of course, is a legacy version, but it'll get the concept across. So for every single Ethereum transaction, it costs exactly 2,100 units of gas, or 21,000, excuse me. That's for a basic Ethereum transaction where you're just sending cryptocurrency from one account to another. If you're swapping tokens on MetaMask with, Uniswap, or you're buying or selling NFTs, the gas cost is going to increase dramatically because you have greater computational overhead for doing that. But for a basic example, it's 21,000 units of gas, all right? And then what you do is you multiply those units of gas by the gas price. So let's just say the average is 30 Gwei. All right, these are legacy values, but we're just going to say that this is the amount of gas, like the gas in your car, and this is the gas price. Let's say, your gas price is $4 per gallon, or, however many dollars per liter in your own country. Okay, you basically multiply the amount of gas that it takes to make the car go by the gas price, and then you see what that's actually going to cost you. So this basically will turn into a transaction fee of 0.00063 Ether at the current gas price. Again, this 30 Gwei has nothing to do with the actual transaction cost in real terms. It's just the price of gas. This is the amount of gas. So you multiply these two things, and then you convert it back to Ether. And this is what the actual Ether cost is going to be for sending that transaction. And this is the dollar amount based on the cryptocurrency price, the USD to Ether price that you would pay for that specific transaction. Now let's talk about smart contracts. We're going to get into this a lot more in this program, all right? You're going to code out a lot of smart contracts, especially when we build that capstone project. But again, this is what sets Ethereum apart initially from Bitcoin. We've seen lots of other blockchains follow suit. So again, smart contracts are really just programs that run on top of the blockchain, okay? You could think about them like building blocks of decentralized applications. Any Dapp that you might have used already, whether you're swapping tokens, buying or selling NFTs, doing DeFi, has multiple smart contracts that all talk to one another that make up these complex decentralized applications. And you can think about them like vending machines. So if you're going to send cryptocurrency to a smart contract, you know that it's always going to put out the same thing every single time. You can trust them. They're auditable. They're transparent. And most of these smart contracts are written in the Solidity programming language, which we're going to cover extensively inside of this program. All right, and as I've said throughout this presentation, is that Ethereum has a long history behind it, and it also has an extensive roadmap ahead of it to improve upon Ethereum. That was the whole idea of the Ethereum blockchain in the first place, was basically to ship Ethereum 1.0 as a prototype and get users so that it could be a leading blockchain platform. That's what it's done. But let's talk about the future. So here's some of the current limitations to Ethereum that are being addressed. Some of these have solutions right now, and we have lots of other solutions coming down the pike. So some of the biggest, problems with Ethereum layer 1 as it exists right now, if you're going to use it, is that it can be kind of slow to use, and it can also be very expensive to use at times, especially when peak network activity happens. One of the biggest reasons for this is because Ethereum can only process about 15 transactions per second. That's what this 15 TPS stands for. And so when there's a lot of people trying to use the network at the same time, that's why the gas costs increase. You see that, GWE number go up a lot. It's because lots of people are trying to use the chain, and it can only process 15 transactions at a time in a 1 second window. So Ethereum is also affected in its performance by its block time. So it can only process 15 transactions per second, but it can only create a new block about every 13 seconds. So this number kind of goes up and down. This number kind of goes up and down too. But these are the current limitations. And for that reason, it makes it expensive with the gas fees, because again, this fee is based on a market, how much demand there is for the chain at any given time. So let's look at some of the solutions for this. So the Ethereum roadmap and the final vision for Ethereum is to move towards Ethereum 2.0. Now that's the long running name of the final version of Ethereum. Sometimes they don't really call it that anymore. But that's the initial roadmap that was set forth by the Ethereum Foundation. So part of making Ethereum faster and cheaper to use is doing something called layer 2 scaling. So we're going to talk about that more extensively in a dedicated section, but I just want to give you the overview now. Essentially, this is where you create a second layer on top of Ethereum. So if you're using Ethereum, you can consider that like layer 1. And Ethereum layer 2 is like a separate blockchain that sits on top of the network, where you can do a lot of the transactions in that environment. And then the result of those transactions can get settled back onto the main Ethereum chain. So this uses Ether itself to pay the gas fees on these networks, and it makes it much faster, much cheaper to use. And then it can use Ethereum security model to make this work. It's kind of like a different blockchain, but it is inextricably linked and piggybacked on top of the layer 1 Ethereum. It can't operate without it. So that's the future of the modular blockchain. Okay. So basically building blockchains in layers. That's what this is right here. And we have lots of layer 2 scaling solutions right now that you can use. We'll talk about that later in that video. But we're going to see more layer 2s come onto the scene and actually gain adoption over time. And that's the end game for Ethereum scaling, to make it faster and cheaper to use. We don't have to wait for the entire Ethereum roadmap to be completed to get that benefit now. Now, one of the last things on the Ethereum roadmap, while there are many more, is sharding. Okay, and this is one way that's also going to make Ethereum much faster, is essentially to take the blockchain and break it up into multiple blockchains, so that the entire network is not responsible for confirming every single transaction on the network. You can delegate that responsibility to smaller groupings within the blockchain, and that's going to give an additional scaling benefit, which multiplies the scaling benefit that you get from these Ethereum layers. And so it'll be some time before sharding gets implemented on Ethereum, but it's on the roadmap, and that's what the final vision for Ethereum looks like. All right, so that's an overview of Ethereum, its past history, how it came onto the scene to make such a big name for itself, why it's such a big deal, why developers are flocking to this ecosystem to build the next generation of decentralized applications, and where it's headed in the future. So with that being said, let's jump into the next video.